All right, Siri has picked number 14. So let's talk about 14 and what this even entails. Oh, for God's sake. All right, so here's 14. Just kidding. There we go. Zoom in a bit. So the directions say, first we're going to state the possible rational zeros, and then I need to find them all. Well, okay, so this time you'll notice they did not say, hey, here's one of the answers to get you started. So it's on us, but it's okay, it's okay. All right, so we need to find our really cool list. So I want factors of 5, which are just 1 and 5. And then I need factors of my lead coefficient, which is just 3. Yes. Okay, great. So my really cool list of possible rational roots. It's going to be positive and negative, all of these numbers. Ready? Well, you tell me. What's in my list?
1 and 5.
That's it. Does everybody agree? And you see where those came from? I took 1 and 5, divide them by 1, and then 1 and 5, divide them by 3. And there they are. Now we're ready to go. They didn't give me one to start off with. Darn it. That's okay. How many total answers am I going to find? There's going to be 3 total answers. Remember, it may not be 3 numbers from this list, because I could have irrational or imaginary solutions, right? Remember that? So it's possible, but I'm going to go ahead and I'm going to plug these in, and I'm just going to go down the line. I don't know which one's going to work. So here's what I do. I said, oh, you know what? Oh, I get to tell you about this cool trick with this one too. So let's make sure we don't need any 0 placeholders. 3, 2, 1, none. Okay, good to go. So I'm going to bring down my coefficients. 3, 4, 16, and 5. And now I'm going to plug in numbers in this list until, what am I looking for? What am I trying to get to happen?
0.
0 as a remainder, which, let's think about this. If this number right here needs to be a 0, that means this number right here would have to be a what? A -5. If you plug in +1, I already know it's not going to work. How would I know that? I need this number to be negative. Look at what just so happened in this one. All of these numbers are positive. So if you plug in a positive number, aren't you going to get positive, 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 positive? You're never going to get a -5 right there. You get what I'm saying? Are you with me? Watch, I'll do it once really lightly. Hi. Sure. So don't write this one down, but I'll show you. If I plug in a +1, watch what happens. 3, 7, 7, 23, right? Look, I'm never going to get a negative number over here. It's always going to be positive. So a +1 is not going to work. None of the positive numbers are going to work in this case, right? If some of these had been negative, then I wouldn't know. I'd have to plug in everything. But every now and again, you get lucky with something like this, where if all my coefficients are positive, I don't have any positive roots. How could I? So I actually get to cut my list even further down, because none of the positives are going to work. I just plug in the negatives. So I'll start by plugging in -1, and we'll see what happens. -3, 1, -1, 15. Nope, that's not going to work, right? So I stop. All right, -1's not it. Let's try -2. Oh, not -2. That's on my list. Just kidding. -5. Well, let's see. Oh, that's not a 9. That's an 11. -11. +55 now. Yeah, I'm not getting there. Okay, -5's out. Let's try, all right, I'm gonna have to try fractions, but you know what? It actually usually works out better than you think. So let's plug in 1/3. Ah! Can someone invent a mechanical pencil that like I don't snap constantly? I don't know, that's my life. Anyway, 1/3 times
Coconut
3.
toasted Cheerios.
What?
Invent that.
Oh, and what am I doing? These are supposed to be negatives.
That was so good.
Invent what about Cheerios?
Toasted coconut Cheerios.
Oh, that sounds really good.
I know. I had it before. It's a fever dream because I can't find them, and I looked them up. I've done everything to find them, and I can't find them anywhere.
But you've had them?
But I swear I bought 2 boxes.
Parallel universe.
It was like before like COVID happened. The best Cheerios I've ever had. I'm like, someone please call them and we can make $1 million idea from an idea that was probably already happened, but I can't find them anywhere. And I've looked them up. I've been like, yeah, those. Just order like a stock of them. Ooh, they're so good. Like, I like Cheerios. So.
And look what just happened. Oh, I'm sorry. You guys don't even tell me that I'm off. Ah.
Those two.
-1/3
Yeah, you clearly did not look it up.
works. Imagine if you called Cheerios and was like, I've got an idea for you. They're like, it's at the grocery store. So
Well, good
Nice
thing
try.
I didn't call them.
yeah. Okay, so -1/3 worked. Do you agree? All right. So now I know that that's one of my answers, right? So if I'm going to keep my list, I don't know, I'll put my list right here of all my answers. I know there's going to be 3 altogether. I just found out that -1/3 is one of them. Also, just, I don't know, if this were multiple choice, for example, I know for a fact that all the positive numbers don't work. -1 didn't work and -5 didn't work. So if it was multiple choice and I listed any of those numbers, I know that they don't work. So those would have to get thrown away. All right, anyway, now we're down to this. Remember, that's your remainder. Constant x to the first x squared. You're down to a quadratic. You can solve quadratics. You don't have to keep doing synthetic division anymore. You have a quadratic like this. Let's make our lives easier and divide both sides by 3, right? So if I divide you by 3, divide 0 by 3, it just goes away. So I now have x squared plus x plus 5 equals 0. And now all I have to do is solve this thing. Unfortunately, it doesn't factor anymore, right? There are no factors of 5 that add to 1. Too bad, so sad. So now I would just go to quadratic formula because I went completely. What's the matter? Mm-hmm. So let's quad formula this thing and see what our final 2 answers are. So I think I can sneak it in over here. So -1 plus minus big old square root. B squared is 1 minus 4 times A is 1 times C is 5. All over 2A. I'm skipping some steps as I'm doing the quad formula because we've already done an entire chapter on it. So I assume that you know what I'm doing. So if you're like, I have no idea where these numbers are coming from. Yes, I'm sorry. Notice I got a negative under the square root, so that's got to come out. So I get I root 19 over 2. And there are my remaining 2 answers, which makes sense because according to the imaginary root theorem, if you have an imaginary solution, which I do, it never comes to the party alone. It always brings its conjugate pair. And it did. You two. So they're going to come up and be my solutions 2 and 3. when we go to graph this thing, which I was hoping we'd get to today, but we might not. I don't know. We'll try. I know that this thing would only cross the x-axis at a -1/3. The imaginary roots, they're not, the x-axis is all real numbers. So if I have imaginary solutions, you're not crossing there. It has to be a real number to cross that x-axis. Anyway, I was tasked to find all three and I found them. Yes. Try one more before we step things up another notch. Okay, let's try one. Oh, these all only go up to the 3rd. Isn't that a 4th? Oh, okay. How about, I don't know. Anybody have a preference? Pick one on the back page. 15 and 22. 16? All right, 16. 16 is a good one because you gotta remember something here.
Find a filler.
Yes. So let you start. Find that list of possible rational roots. So make that really cool list that we start with. Okay, you have the list? All right, your list of possible rational roots should be positive and negative, all of these. 1 and 1/4, that's it, right? Oh, 1/2 too, yep, you're right, I forgot. Thank you. And that's it, right? Factors of this number, which is just 1, divided by the factors of this number, which is 1, 2, and 4. So yes, 1, 1/2, 1/4. All right, cool. So there they all are. Now I need to do synthetic division until someone gives me a remainder of 0. When you go to do synthetic though, I hope you remember I have to the 3rd, but I don't have an x² term. So you have to put in a 0 right there. So there's 3, 2, my coefficient of x to the 1st is -3, and then 1. All right, so now go ahead and find me the number. Oh, you don't get to do that cool trick from the last one, right? Because they're not all positives. So you can't just automatically rule out the positives. So now you're just, so I always start with 1, right? Because it's easy. Start with 1, and then I try -1. And then I'll move on to 1/4, and then I'll try -1/4, and then I'll try 1/2, and I'll try -1/2. It always seems to be the last one you try. So it really doesn't matter the order. You just got to plug them in until someone gets you a 0. So everybody try it, and we'll see if we match. And as soon as, so I stop right here because I'm like, oh, it's not going to work. So I stop. And I got to go back. I got to try another one. I'm going to try. Oh! Yes. How'd we do? I found -1 work. There might be, because how many total solutions are there going to be? 3. There might be other ones in this list that work. By the way, remember that you can have such things as double roots. It's possible that -1 is a solution again. I have no idea, but I'm down to a quadratic now. There's my remainder. There's my constant, x to the 1st, x². So now I have this quadratic, 4x² minus 4x plus 1. And I can solve quadratics all day long because that was our entire last chapter. So I'm gonna try and factor this thing. Let me see if I can do slide and divide here. X squared minus 4x plus 4. Are there factors of positive 4 that adds to be negative 4? Yes. Minus 2 and minus 2, right? I did the slide, now I do the divide. Oh, look what happens this time. How cool is this? You can rewrite these as 2x minus 1s, but isn't the solution that I'm going to get from them the same? So the one solution I already found was -1. I found out that that worked. And then don't I get a solution of positive 1/2 2 times? Are you with me or not so much? Yeah? So I get positive 1/2 as a double root. You might have rewritten these ones as 2x minus 1. 2x minus 1. Either way, you're going to get, like when you solve that, that becomes positive 1/2, and you get it twice. Isn't that something? And so I was supposed to get 3 answers. I got 3 answers. I just so happened to get positive 1/2 as a double root. Now, when I was plugging in numbers and I didn't know which one was going to work, if anybody had plugged in a positive 1/2, that would have worked. You could have plugged in a positive 1/2 from the beginning, and you would have gotten a 0 as a remainder. Wow. I know. Okay, so we're feeling a little bit more confident with these, I hope?
Yeah.
Okay, so now we're gonna up the ante again a little bit. Are you ready?
Yes.
Okay. I'm actually gonna backtrack to number, oh wow. These are worse than I was expecting, but we got to do one of them, at least one, so you can see how it's done. Let's go back to number 9. And I might even, yeah, I don't know. I might use a, whatever. All right. So this is back on the ones where, so just like last night's homework. So I want to start by giving the list. They did give me one answer though. They said, hey, here's one of your answers. Now that's not a rational answer, but that's okay. So what they actually gave you was 2 answers, didn't they?
Yeah.
What's the other one? 1 minus 2i, right? That is the imaginary root theorem. If one of your answers is imaginary, it brings its conjugate pair to the party. So as I'm making my list of answers, how many am I going to have altogether? You're going to have 5 altogether, right? Because the degree is 5. They gave me 2 of them. I have not just 1 plus 2i, but 1 plus and minus 2i. You can write them separate or you can write them together. It really doesn't matter. An imaginary or an irrational automatically brings its friend to the party. Now, this is a little bit trickier because now if you think of what we did in the other ones, after I made my list, I would plug in numbers from that list, or if they gave me a 0, I plugged in that 0 because I know that that one works. So I can do that, but it's weird. So you can do synthetic here. Gosh. But I have 2 answers, right? So it would be so nice to sort of use them both at the same time and knock this down from being an exponent of 5 down to an exponent of 3 and one nice swoop. You can do that. I'm going to show you this technique. It's a little weird, but once you get the hang of it, it's really not so bad. And I want to show you, bless you. I'm going to take you on a little side journey for a moment. Okay, so put a pin in your brain in this and come visit with me. I'm going to take you to another land of math magic. Are you ready? So we're here. We're gonna do an easy example, then we'll come back to this weird one. Let's say I have some quadratic, I solve it, and the solutions are, who cares? Let's say 3 and 5. These are my two solutions of this random quadratic. So this thing is going to cross the x-axis of positive 3 and positive 5. I want to work my way backwards and actually figure out what the quadratic was that had these two things as answers. So let's think about this. If I get 3 as an answer, what was the factor that came from? I'll tell you on this one, then you can do the one for 5. Wouldn't this, to get an answer of 3, wouldn't it have had to have come from x minus 3? Wouldn't that give me a positive 3 as a solution? So what is the factor that the 5 must have come from? X minus 5, right? So if I'm trying to figure out the original quadratic that had 3 and 5 as answers, couldn't I now just FOIL these two things together? I sure could. So I'd get x squared minus 5x minus 3x would be a minus 8x, and then a plus 15 on the end. You with me so far? Is that okay? So if I went the other way around, so if I pretended I didn't have this, and I had this quadratic, I could factor this thing. So that, oh yeah, factors of 15, that has to be -8, -5, -3. Boom. Solve it. Boom. Right? So I'm just working backwards for a second. But I want to show you a shortcut. Are you ready for the shortcut? If you have any two answers, any two, you can come up, you can actually kind of jump right to that. Because this thing in the middle, do you ignore the minus for 1 second, but what does 8 have to do with 3 and 5? It's their sum. And what does 15 have to do with 3 and 5? Oh! So get this. In order to figure out the quadratic that two solutions come from, here's the general formula that you're going to use. So the general formula. Ready? Oh, let me get this in the screen. This is fascinating stuff right here. It's going to be x squared minus the sum of your roots times x plus the product of the roots. You should write that down somewhere because that's super useful. And it works even if you change the signs. It doesn't matter as long as you always do minus whatever the sum is plus whatever the product is. So let's try another example where the signs are different. So let's say your solutions were -2 and 7, whatever. This over smidge. There we go. So if I just jump right to the general formula, it'd just be x squared minus, what's the sum of these two things? 5. And then the product of these two things would be -14. Oh, wow. Right? So I'm just sort of skipping the step in the middle where I have to like FOIL them together, write the factors and FOIL. Let's try one more just for good measure. What if I gave you, let's do 2 negatives. How about -3 and -4, whatever. So you try that one, right? What that quadratic would look like. Okay, did you write, or you tell me what you wrote, x squared? Keep going. Yes. If I find their sum, that's -7, but I want minus -7. That's why that one turns into a plus, right? Minus -7 turns into plus, and then -3 and -4 turns into +12. We are going to use this same idea now that we've taken this nice little journey elsewhere. Well, let's do one more example where it's imaginary before we go back to the one that we were just doing. So what if my solutions were, how about 2 plus I and 2 minus I, right? So there's a conjugate pair. I'm doing the same thing. So what's the sum of these two things? You add these two together, what do you actually get? 4, right? 2 plus I plus 2 minus I, the plus I and the minus I are going to cancel each other out. How cool. So the sum is just 4, and then the product, you multiply these two things together. So I'm doing 2 plus I times 2 minus I. So take a second and figure out what that product is. So I'd get 4 minus 2I plus 2I cancels each other out. And then the last plus I times negative I is a negative I squared. But what is I squared really? -1. So minus -1 turns into 4 plus 1. The product is actually 5. You see that? So I mean, I have to do a little bit of work out. It's not as easy when it's just regular numbers. I can just do it in my head. But now I have the sum and I have the product. So I just pop it in the formula. Check this out. X squared minus the sum plus the product. You with me so far? All right. So now let's travel back to number 9. So we're here. Number 9 has told me, hey, you have these two as zeros. Why don't I figure out what the quadratic is that produce these two zeros? And then once I have it, you might not like this part, but once I have that, I can do long division into this. And I could get down to a quadratic that I can then solve. Oh my gosh. You ready? Buckle up. Yeah, you with me? Stay with me, people. This is exciting. You're on the verge of what a discovery. Ready? All right, so let's figure out the quadratic that has these two zeros. So step 1, let's even write those so you know what's going on. Find quadratic with these two things as zeros. So first I need to find their sum. So if I have 1 plus 2I plus 1 minus 2I, what's my sum? The plus 2I and the minus 2I are going to cancel. I just have 1 plus 1. So isn't the sum just 2? Right? You with me? Now let's find the product. So I'm going to do 1 plus 2I times 1 minus 2I. Foil these two things out and we'll see what comes out. So first one outside minus 2I, inside plus 2I. They're always going to cancel. But then the last is a minus 4I squared. What's that really? I squared is really a -1, right? So I have -4 times -1 is now +4. 4 plus 1 is, don't you get 5? I get 5. Because this whole chunk turns into a +4. So now that I have those two things, I have the sum of the product, I can write the quadratic. So these two things come together to become x squared minus 2x plus 5. And now, my friends, we are getting closer. Step 2, I'm going to take that quadratic and do long division. I can't do synthetic because it's not a binomial. Do long division into original. Okay, you ready, spaghetti? You guys have got this. Don't fret. So we're gonna do x squared minus 2x plus 5. Was this someone in this class yesterday, or maybe it was D Block? They were like, how is it like one problem is like everything we've learned all year? Like, yeah, kind of. Weird how it all comes together, right? I know. 3x to the 5th minus 13x to the 4th. Was it you guys or no? No. We could review for the final, just doing like one problem, right? Oh,
Did you learn how to do a quadratic?
with a trinomial? It's, you do the same thing. There's just more things to bring down. Oh, of course, I have a hole punch right where I need there not to be one. Do you want to change tactics? I have a different idea. Yeah.
I had a question about like sum of the product.
Yeah.
of the two. Don't you like add those together and then find if it's the quadratic? Like it was with the other sheet.
Hold on.
I don't know.
Let me look. So you want oh,
Oh, wait, never mind. I was thinking about this.
you sure?
Yeah.
Okay.
that makes sense.
Well, I have another strategy for this particular one. We can do long division. Or I'm just looking at this list because our possible rational roots for this one are so little. Right? Because my two n numbers are prime, 5 and 3. So we could just do synthetic instead to get down to a smaller answer. I don't know. Or we could do synthetic, find one number, and then maybe I could do long division into that one.
It's just a lot.
It is a lot. So you know what? I'm gonna change step 2 in here. Take that quadratic and do long division into original, or do synthetic. If you prefer. Using rational. So, do you prefer synthetic, I assume? Instead of doing this crazy long division problem?
Yes.
All right, so let's, we're gonna vote for option 2. So my list of possible rational roots is not even that long. It's just gonna be positive, negative, 1, 5, 1/3, and 5/3. So let's see if any of these work. 5, 4, 3, 2, 1, none. All right, who's gonna work for us? Let's keep our fingers crossed for 1. Yes. We now have 3 of our answers. One just worked. I don't know if you tried it yet or not. So I'm gonna put it back up at the top. There's my one that I know works.
Can you go back on?
Yeah. Down, up, sorry. I moved it all over.
Can you go back down?
Yeah. There we go. Sorry. There it is. So if I were to, where am I at? So there's my remainder. Constant x to the first squared, third, fourth. So now you're back to 2 options. You can either do long division with this new thing, but at least this is only x to the 4th, so it's a little bit better with this thing that we came up with in step 1. So, because I know that this divides in evenly. I know it does. So it's now my choice. Do I want to do long division now? Or since our list of possible rational roots is so small, we might just want to keep going and see if we can find another one. The problem is, if there might not be any more possible rational roots. Oh wait, is there how many? Yeah, I may not have any more. So I could run through this whole list and not find another one. Or I could run through this list and find another one. And then it would make my life that much easier. So it's kind of personal preference right here. You can do long division and know, hey, once I do this long division, I'll be down to a quadratic and I can solve it and get out of here. Or do you run through the rest of the numbers doing synthetic and hope to find another 0? So that's kind of your choice. I don't know. What do you want to do? Do you want to do synthetic or do you want to do long division now? Well, since we have a whole group of people, let's divide and conquer. So I don't have to, I get to use these new coefficients now. So I'm going to keep doing my synthetic with just these coefficients. I don't need the constant or the remainder anymore. That's off. So I don't need this. So I'm going to keep doing these and I'm going to keep going through my list. I do try +1 again because it could be a double root. But why don't some of you try -1? Why don't some of you try 1/3? Or I'm sorry, what about 5? Some people try +1, some try -1, some try 5, try -5. And we'll see together if we can find one fast. And once you realize something's not going to work, I found one. One works again. Oh my gosh, what luck. So I now have 1 as an answer 2 times. I have 3, 4. The last answer has to be rational, right? Because I have 1, 2, 3, 4. I only have 1 solution left. So it can't be imaginary. So I know it's got to be in this list. Let's find it. So we can do synthetic again with these new numbers: 3, -7, 17, -5. 1 could work again. So again, split, it's divide and conquer. Some people plug in 1, do -1, 5, -5. Let's have a race. Who could find it
There's
first?
so much, I don't even know. Oh, here are the numbers.
What is it? 1/3. All right. Okay, so now I think I have everybody. So I had the 2 that they gave me. Then we found 1 as a double root. So there's 1, 2, 3, 4, and 1/3. Now, what happens if the other roots, we got lucky that they were all rational. They may not be rational. Then you're gonna have to do long division at some point. Because if I have no more rational roots that are working, I'm gonna have to do the long division, and that would get me down to the quadratic that I can then solve, either doing the quad formula or continuous square. All right, so we didn't get to anything that I wanted to today. I mean, we needed to do this stuff anyway, but that's okay. So why don't I have you guys try for homework this evening? Remember on 16, how this one wasn't so bad? None of this crazy stuff with imaginary numbers, it was just normal. Why don't we try some more that are like this? So remember what we did. We made our fancy list, and then we plugged in numbers until I got a 0. And these are all only degree 3. That means once you find the first 0, whatever is left is going to be a quadratic that you can solve. You get what I'm saying? So these hopefully aren't too bad, because you're just going to plug in numbers from this list. Someone's going to work, hopefully. Actually, yeah, someone has to work on all of these. So there's going to be a rational root, and then you're going to be able to solve that quadratic. So let's just focus on these, maybe. I think I'd be happy there. How about we do the odds on this last page? 15 to 21. I think that seems okay. All right, so odds, numbers 15 to 21. Back of this page. If you want to check any of your answers before you leave, let me know. I'll have them. I'll go open this on Jupyter in a second. Yeah.